So let's continue from the life cycle of fungi. When we talk about fungi, there are two categories based on their nutrition. There are three categories. We have the saprophytic fungi, we have the parasitic fungi, and we have the mutualistic fungi. So when you talk about the life cycle of fungi, we are going to talk about the classification based on nutrition. So we are going to talk about what saprophytic fungi is and what parasitic fungi is. So when you talk about saprophytic fungi, these are the kinds of fungi that feeds on dead or decaying organic matter, non-living tissues. So these fungi are able to feed on non-living tissues because they secrete digestive enzymes. So these enzymes are the amylase for digestion of starch, the lipase for digestion of fat and oil, as well as the protease for digestion of protein. So these enzymes are secreted and they break down this food extracellularly. So this group of fungi obtain already digested food. So they break down their substrate. So they are called saprophytic fungi. They do not cause harm to the host, the saprophytic fungi. So they only obtain food by secreting digestive enzymes. And when we talk about saprophytic fungi, we said that they feed on non-living tissues. The examples of saprophytic fungi are yeast, Saccharomyces, Rhizopus, Mucor. Examples of saprophytic fungi, those are examples, Penicillium. Those are examples of saprophytic fungi. But on the other way around now, the parasitic fungi, let's compare the two now. The parasitic fungi feed on living host, living tissue. They feed on living tissue, while saprophytic fungi feed on non-living tissue. The parasitic fungi feed on living host tissue. They cause harm to the host. That is, they cause diseases. They also lead to death of the host. That is the parasitic fungi. The parasitic fungi, there are two types of parasitic fungi. We have the obligate parasite and the facultative parasite. The obligate parasite live the entire life on the host, while the facultative parasite can live both saprophytically and parasitically. So the facultative parasite feed on the living host tissue and they also kill the host. After that, it will now feed on the dead matter. So that is why it's able to feed on both living and non-living matter, the facultative parasite. So when we talk about parasitic fungi, there are some parasites like the facultative fungi. They also secrete pectinase, enzyme pectinase. Alright, the parasitic fungi. These enzymes digest the tissue, the middle lamella of the plant, because they affect plant. So they cause soft rot in the plant tissue. They cause soft rot. When they secrete this enzyme, the enzyme will digest the plant tissue, thereby causing disease to the plant. So example of parasitic fungi is Pythium dibranum. Alright, is Phytophthora festus that cause potato blight. Pythium dibranum. Those are examples of Pythium. Those are examples of parasitic fungi. So now we want to understand the life cycle now. So let's start from when we talk about mutualistic fungi. They are the fungi that have relationship with another organism. They have symbiosis relationship, close relationship with another organism, and they share properties, they share characteristics. Let's move to life cycle of, we still talk about mutualistic relationship. Example is lichen later, but let's talk about the life cycle of saprophytic fungi now. Life cycle of saprophytic fungi now. So we are going to consider mucor. Mucor, the habitat of mucor is usually, moist, decaying food, non-living material, decaying food like your rice, your eba, your potato, eba that has been in the kitchen for like 3 days, 4 days. You start seeing some white fish or a brownish thing coming out. Those are mucor. So mucor are found on decaying food materials, cooked food that is already decaying. So the structure of mucor, they usually looks like cotton wool, like white cotton wool on our decaying food. Those are mucor. Those things that look like white cotton wool on our decaying food. That's what is referred to as mucor. And this mucor, the structure is that they have a non-septate hyphae. The mucor have non-septate hyphae, and they carry out saprophytic mode of nutrition. They secrete digestive enzymes when they penetrate their substrate. So mucor is something like this. So when you talk about mucor, let's say this is mature one. This is our sporangium. We have the spore. We have the sporangiophore. So this is the stolon, horizontal hypha. This is the rhizoid, root-like hyphae. So that is the structure. That is the structure of mucor. So that is the structure of mucor. The sporangium, the spores inside the sporangium. We also have columella. This is called columella. So let's talk about the reproduction now. We have understand the structure. So let's talk about the reproduction now. We have sexual and asexual reproduction. So let's talk about the asexual reproduction first. Asexual reproduction in mucor. So when we talk about asexual reproduction, refers to a type of reproduction whereby a single parent, give rise to offspring, numerous offspring. So in mucor, the asexual reproduction in mucor occurs by spore formation. So we should take note of that, spore formation. So when we have asexual reproduction, we have just one single mucor. So what happens is that the first thing, how do we have asexual reproduction? When the first thing is the development of hyphae. There will be an hyphae that will develop from the substrate. So the hyphae will develop and to go to the air, bearing a single sporangium. So when an hyphae develops and bears a single sporangium like this in the air, okay, the next thing is that this sporangium will bear a swelling at the head region. So the next thing is that it will bear a swelling at the head region. That's the next thing. And this swelling, have some content. So this swelling is refers to as the head, which is the sporangium. So the next thing, later, there will be separation. There will be a dome-shaped structure that will separate, that will cut off the head from the sporangiophore. So at the tip of the sporangiophore, there will be a development of a dome-shaped structure which we call the columella, that will separate the sporangium from the sporangiophore. That is the next stage. So when the sporangium is separated from the sporangiophore, we are aware that this sporangium consists of mass of multicellular, mass. So this sporangium will carry out series of cell division to produce spores. So there will be production of spores inside the sporangium. After it has been the production of spores, so these spores are uninucleate, and the spores continue to mature. As the spores continue to mature, they become thickened and darkened. But the sporangium also becomes mature, and as the sporangium mature, it becomes thin and brittle. So the sporangium, the columella, expand as well. So as the columella build up, as the columella increase, it will, the columella will exert more pressure on the wall of the sporangium. As the columella mature, it puts more pressure on the wall of the sporangium. So further maturity of the columella will make the sporangium to burst. So the sporangium will burst, and we have the spores being dispersed. So the spores will be dispersed, they will be set free. The spores will be released. So this, let's say this is the substrate. So the spores that found itself on a fairy condition will now germinate into a hyphae. So that is how sexual reproduction occurs by spore formation in mucor. Then next we move to asexual reproduction in mucor. So when we talk about asexual reproduction in mucor, sexual reproduction now. So when we talk about sexual reproduction in mucor, sexual reproduction sexual reproduction don't just occur just like that. They occur on certain conditions. Maybe they are in the culture media. So in the culture media, we can have two strains of mucor, the positive strain and the negative strain. So for us to have sexual reproduction, there must be a condition called heterotalism. So heterotalism simply means that there is availability of two different strains. So let's say we have two different strains of mucor in the culture media. So the first thing is that these mucor will grow toward each other. They will start growing toward each other, and this is what is referred to as the progeny. The mucor will grow toward each other to form what we call the progeny. So as they grow toward each other, they will develop a swelling, and they will attach or they will adhere to each other. Let's say they go towards each other, so they will develop a swelling. They will now adhere to each other to form the gametangium. So when they grow toward each other, the next thing is that they will adhere to each other to form the gametangium. So let's say this is the progamete. They will now form a gametangium when they adhere to each other. So this gametangium also have what we call a suspensor. The lower part of the gametangium is the suspensor. So as the gametangium mature, the wall of the gametangium will break away from this part. Let's say this is the gametangium. Okay, this is the progamete. So this is the gametangium. The gametangium, let me draw it somewhere. So we have our gametangium like this. So this is our gametangium. So as the gametangium mature, the wall of the gametangium will, break, and the gamete of the gametangia are fused together to form the zygospore. So the wall of the gametangia will now fuse together to form a zygospore. So this is the life cycle. So this zygospore, this is a young zygospore. Young zygospore. Young zygospore. So this zygospore will develop a coat to form mature zygospore. So after this stage has taken place, we now have the zygospore will now develop so the zygospore will now germinate to a new hyphae. So this is a new hyphae called promycelia. Promycelia. So this promycelia will now develop into a mature mycelia. So this is how the sexual reproduction is achieved. The two, are different strains will come together at the head region. So they now form the progamete. The progamete will divide into two. We have the suspensor and the gametangium. The gametangium will break, and there will be, formation of the gamete, and this will give rise to the young zygospore. So the young zygospore will develop in a favorable condition and give rise to the promycelia. So now let's move to the life cycle of parasitic fungi. So when you talk about the parasitic fungi, we are going to look at Pythium dubreanum, Pythium dubreanum, so let's say life cycle of parasitic fungi. So let's say we are taking Pythium. Pythium carry out both sexual and asexual reproduction. The sexual reproduction is just like that of the mucor. The mucor and rhizopus is almost the same thing. But we have two conditions where we have wet condition and dry condition. So when we have Pythium, the first thing is that there will be a development of hyphae into the end. So this hyphae will now develop swelling at the head region. So this swelling will now develop into either a conidium or a sporangium, because they can produce sporangium, spore formation. Their spore can be spore, zoospore. They can produce zoospore or conidium or conidiospore. So the kind of spores that is produced will depend on the environment where they are found. So we are saying that when they have already developed swelling at the head region, if they are found in a wet environment, they will develop conidium. So they develop if they are found in wet region, they develop zoosporangium. So the zoosporangium will form zoospore. But if they are found in dry environment, they develop conidia, and this conidia will produce conidiospore. So that spores will now become mature. Upon maturity of the spores, the conidia, the zoosporangium or the conidium will break, and these spores will be released and dispersed, and they will germinate into a new plant. That is asexual reproduction. So it depends, but if it is zoosporangium, before it will infect, it's a parasitic fungi, Pythium. Before it will infect new plant, the zoospore will swim, it will move, a little. But if it's a conidiospore, it will not swim, it will not immediately they are formed, they will infect new plant. So they will start growing in the tissue of another plant from the spore. So the next one is the asexual reproduction now. The sexual reproduction now. Sexual reproduction now. The sexual reproduction in Pythium is carried out by fusion of gametes, conjugation. So what happens is that the first thing is the hyphae will grow, and there will be development of female sex organ called ogonium. The female sex organ called ogonium. So this ogonium will now produce what we call the oosphere. Okay, and The ogonium consists of the oosphere and also the peripheral part. Then the other, the male sex organ. The male sex organ is called antheridium. Antheridium. And this antheridium also consists of the central part as well as the peripheral part. So we have understood that inside this male sex organ there is production of oosphere. The ogonium produce oosphere, while the antheridium produce antherozoid. Antherozoid. So the antherozoid, the antheridium form what we call a fertilization tube. It looks like a beak. So this antheridium will grow toward the female. It develop a beak, and this beak will fuse with the ogonium and fertilize the oosphere. So the antherozoid and the oosphere will fertilize, and they will produce a zygote. So this zygote will now carry out cell division and give rise to another hyphae. So it now depends on maybe they produce a spore. So it now depends on maybe it's a positive strain or a negative strain. So that is how they carry out their life cycle. So after the life cycle of pythium, we are also going to talk about the economic importance. Before we go to leaching, we are going to understand the economic importance of fungi. Are fungi useful? Are they important? Are they beneficial? Who they help? Do they serve our economy? So first of all, the fungi serve as source of food. Let's say mushroom serve as source of food for man. Serve as food for man. Okay, and other animals. Okay, the fungi, the one that carry out mycorrhiza. There are some fungi that carry out mycorrhizal relationship, thereby increasing the nutrients in plant. Increase the nutrients in plants when they carry out mycorrhizal nutrients in soil. They carry out mycorrhizal relationship. They also carry out decomposition. They act as decomposers. Those are economic importance of fungi. Economic importance of fungi. We said they act as decomposers. Some fungi are used in the production of antibiotics. For example, penicillin. Penicillin is produced from penicillin. So penicillin is a fungi. So they are used in the production of antibiotics, e.g. penicillin, in the production of penicillin. So we also have another one, production of plant hormones. That is from hormones such as gibberellin, from Gibberella fujikuroi. Gibberellin. They are also used in the production of some enzymes. They are used in the production of enzymes. They are used in the production of hormones. Okay. Fungi are very important. They are used in baking. For example, yeast. They are used in baking. Example is yeast. They can also be used in the industry, in the pharmaceutical industry. They can be used in medical. They can be used in medicine. Those are the common economic importance of fungi.